Welcome. Today, we'll solve a challenging integration problem. We need to integrate x divided by x to the fourth plus x squared plus 1 with respect to x. This is a rational function where the degree of the numerator is less than the degree of the denominator. To solve this, we'll use partial fraction decomposition. First, let's analyze the denominator. This denominator is a fourth-degree polynomial that cannot be factored over the real numbers. However, it can be factored into two irreducible quadratic factors. Let's call them a and b. To find these factors, we can expand the right side and compare coefficients. When we multiply these quadratic factors, the coefficient of x cubed and x must be 0, since they don't appear in our original polynomial. This gives us a system of equations. The coefficient of x cubed must be 0, so a plus c equals 0. The coefficient of x squared must be 1, so b plus d plus ac equals 1. The coefficient of x must be 0, so add plus bc equals 0. And the constant term must be 1, so bd equals 1. Solving this system, we find that the denominator factors as x squared plus x plus 1 times x squared minus x plus 1. Now, we can write our integral as a sum of partial fractions. The numerator x can be written as a times x squared minus x plus 1 plus b times x squared plus x plus 1, where a and b are constants we need to find. Cross-multiplying and comparing coefficients, we find that a equals 1/2 and b equals negative 1/2. Therefore, our integral becomes 1/2 times the integral of 1 over x squared plus x plus 1 minus 1/2 times the integral of 1 over x squared minus x plus 1. The final answer is 1/2 times the natural log of x squared plus x plus 1 minus 1/2 times the natural log of x squared minus x plus 1 plus a constant of integration. And there we have it. We've solved this complex integration problem using partial fraction decomposition.